Good morning, everyone. We are team of three. Our project title is Intelligent Worker Safety System. Coming to the introduction, we already know that industrial safety has already always been a critical concern, with traditional safety systems often falling short in preventing accidents. Our project, the Intelligent Worker Safety System, offers a technological solution using computer vision and IoT based machine control to enhance workplace safety. Our goal is to develop a system that monitors worker movements in real time, provides instant alerts when danger zones are breached, automates machinery shutdowns to prevent accidents, uses state of art deep learning models like SSD or YOLO for accurate detection and decision making. Coming to the system architecture and features, we have two components, hardware components and software components. Coming to the hardware components, we have an IP camera, microcontrollers, and sensors to capture data and control machinery. Coming to the software components, this is where the deep learning models and libraries come into play. In this, we have used YOLO, a fast real-time object detection model used to identify workers and their positions, and SSD Mobile Net V2, which is a lightweight and efficient model used for object detection in edge devices with limited computational power. Our system leverages several advanced libraries and models to achieve these objectives. Some of the libraries used are TensorFlow, OpenCV, PyTorch, Flask for setting up the backend server to manage alerts and communicate with the machine control logic. And coming to MQTT, we have used lightweight messaging protocol to transmit data between devices in real time. And some of the key results and key findings during our implementation are high detection accuracy using YOLO for detecting workers in hazardous zones and immediate alerts with less than 1 second delay using edge processing, through which we have effective machine control where the system could shut down machinery instantly upon detecting boundary breaches. By combining these components, we significantly reduce accident risks. If you see here, this is the coding part section where we have requirements.txt file where we have all Python dependencies required to run the project, and environment YAML file defines the Conda environment configuration, specifying the dependencies and their versions to ensure a constant development environment. And we have a Python file hand detection. This is the main script responsible for detecting hand movements near machinery using computer vision techniques. And we also have a different file called distance to camera, contains the functions to calculate the distance of detected objects from the camera, aiding in accessing proximity to danger zones. And the other file is origin lines Python file, which defines the orientation lines or boundaries within the video feed, establishing safety and boundary lines for monitoring purpose. And we also have some of the test images stored in test images folder. This is a collection of images used for testing and validating the object detection models and algorithms implemented in this project. And here we'll see a live demo of this project.
So I'm going to demonstrate our project. So before starting, I will go through our safety line breach and the boundary line. So safety line breach simulates a hand or object crossing the safety line, showing how the system triggers an alarm in real time. Boundary line breach simulate crossing the boundary line, demonstrating the machinery stopping automatically. And then the system reset, which is showing how the system resumes normal operations once the worker is safe. So here I'm running my code. So you can see here my hand is getting detected by the red line, which is our safety border line. So if I cross this line, this machine will automatically triggers a beep noise, and if I cross the blue line, the machine will stops.